A student takes out a loan of 30,000. Annual nominal interest rate is 9%, convertible semi-annually. Student pays off the loan in 5 years with monthly payments beginning 1 month from today. First payment is 500. Each subsequent payment is X more than the previous payment. So the payments form an arithmetic annuity immediate. Determine which of the following is the equation of value. And now on the left hand side of all these choices, we have the value of the loan, which means the right hand side must be the present value of all the payments. And the payments, as we said, form an arithmetic annuity immediate. But if we use the usual formula for it, then we are not getting any of these choices. So therefore, we have to list out all the payments and then add their present values and then hopefully get one of these choices on the right. So the first thing would be to find the monthly effective rate because we have monthly payments. So 1 plus I12 by 12 power 12 equals 1 plus I2 by 2 power 2. And we write this thing on the right hand side because we are given the semi-annual rate, which is semi-annual nominal rate, which is I2. And so I12 by 12 is the monthly effective rate. Let's call it J. So 1 plus J to the 12 is 1 plus 0.09 by 2 because the nominal semi-annual rate was 9%. So this gives us 1 plus J equals 1.045 to the 1/6. So now the payments happen for 5 years, and in 5 years there are 60 months. And as we said, the payments form arithmetic annuity immediate, and here's the stream. These times are in months. So at time 1 month, we have a 500 payment, and then they keep increasing by X. So 500 plus X at time 2, 500 plus 2X at time 3. So you see at any time, the X factor is 1 less than that. So at time 3, we have 2X. At time 2, we have 1X. So therefore, at time 60, we will have 59X here, and then 500 is being added to all of them. So the present value of these payments should be equal to the present value of the loan, which is 30,000. So 30,000 equals present value of the first one. The first one happens at time 1, so its present value would be 500 divided by 1 plus j to the 1. Second one happens at time 2, so its present value 500 plus x, so 1 plus j squared, and so on. Last one happens at time 60, so we bring it back by dividing it by a factor of 1 plus j to the 60. And in summation notation, this can be written as 500 plus n minus 1x over 1 plus j to the n. You can check the first and the last term to make sure that the indices are correct. So when n is 1, the numerator is 500 plus 0x, or just 500, which is what we have here. And when n is 1, this is 1 plus j to a single power, which is what we have here. And then the last one, 60. 500 plus 59x should be in the numerator, which is what we get when n is 60. 60 minus 1 is 59, so 500 plus 59x. And when n is 60, the denominator here is 1 plus j to the 60, which is what we have here. So we're almost there, except that the answer choices have a numeric value here, which we will get if we recall equation 1, which we found that 1 plus j equals 1.045 to the 1/6. So when we replace 1 plus j by 1.045 to the 1/6, this denominator becomes 1.045 to the n/6. And this is choice E.